Welcome. My name is Felix. I'm co-founder of Viscopic, and Viscopic is a Munich-based company. We are focusing on mixed reality. And basically our background, besides mixed reality, is also building real-time communication solutions for industry, especially like supporting field technicians on site. And today I want to talk about how mixed reality and especially tele-immersion will influence how we communicate in the future. So today communication happens in 2D, right? We are used to transfer HD video streaming from A to B via around the world, and we are usually stuck behind a screen. So there's always a screen behind us, in front of us, and it definitely separates us to our communication peer. So this makes us hard to make social interaction like it would be in the real world. So you cannot do real eye contact and gestures. And I think 3D telepresence is kind of the way we will go in the future, especially when it comes to communication. So telepresence in 3D means you see your communication peer in 3D and you can interact with him actually the same as it would be a real world conversation. We are all familiar with this idea of telepresence, especially in Hollywood movies like Star Wars. We saw, for example, Princess Leia teleported in full 3D. And actually that's kind of an advanced application that we should see here because they don't even use headsets, right? And I think there's definitely a potential, and this is the future of communication. So 3D tele-immersion is a really ongoing research field for years, and we see a lot of applications and publications that happen during this period. So we see, for example, this is actually an application that happened 6 years ago, and this is an application where you can see a teleported stage experience. So the artists are teleported from London to Florida in real time. So how do they do it? They build a really complex stage. It has a transparent layer that has a specific rotation and position on the stage. And using a projector, images are sent or basically projected onto this layer. And it has, there you can visualize a holographic experience. This is, of course, a really large setup, complex setup. And it has the disadvantage that only the audience from one direction can see this holographic experience. So that's why I want to talk about using mixed reality and 3D telepresence. In mixed reality, of course, we have the ability to walk around the scene and see this, watch that scene from every angle. And to achieve telepresence and tele-immersion in AR and VR, there are actually two major concepts you can follow. On the one hand, you can use avatars, of course, like the abstraction of users using artificial characters, or you can use a real 3D reconstruction of persons. Using avatars is kind of a famous thing at the moment. Using all these VR social experiences use these avatars, for example, Facebook Spaces. And it definitely has an advantage. You can be whatever you want, right? You can be creative, you can create your own avatar, but it has a disadvantage for serious application. Just imagine a business meeting where you have to talk to a funny character. It's maybe not appropriate in this situation. So you may think of, or you may say, okay, then let's make this avatar more human-like. Definitely you can do that. You can have a mesh of a person that looks more like a human, and you can make a skeleton within the mesh, and you can rig that, and you can transmit the movement, but then it maybe looks like that. So you're easily stuck into the uncanny valley with this kind of applications. So it's really uncomfortable looking at these kind of avatars. They look maybe like a human, but they don't move like it, and they don't behave like that. So that's why I would say for real serious applications, 3D reconstruction is the way to go. We have two options how to, or the main approaches basically that are currently common to use reconstructed data in, for example, mixed reality applications. On the one hand, we have point cloud reconstruction, like Valorem showed in HoloBeam. We see that from a depth capturing a system, there's a reconstructed model as point clouds, and you can see a person in these small dots that actually behave like a real mesh. On the other hand, you have the real mesh reconstruction. That is, for example, Microsoft is definitely a pioneer in this field. You see Fusion 4D here. So there's a real-time reconstruction of a dense surface mesh. And this is really impressive because this is really hard to do, and there's a lot of computational power behind that. So to build 3D teleportation systems, you have to address 3 major challenges. The first, you have to build, or you have to find a solution for real-time reconstruction, especially for mesh reconstruction. This is really hard because usually you have a capturing system that has several depth cameras or 3D sensors that all create their own point cloud, and you have to align and merge the point clouds. You have to find to fill holes, and you have to texture that and map the textures and so on. So this is a really hard part. On the other hand, you have to compress that data. You just have to think about, usually at the moment, we transfer HD video. It's about 10 megabit per second maximum. And now you have to transfer HD video. It's like the textures of this mesh. And additionally, on top, you have to transfer the mesh data. So you need an effective and really powerful compression technology that all happens in real time. The third challenge is, of course, the visualization. Actually, you all noticed this is close to be solved. Actually, we have the HoloLens, we have VR devices that definitely have a nice capabilities to render high-quality data, high-quality visualizations, and have a really high frame rate, so you can have this kind of applications. And you have a spatial tracking, so you can walk around in the shared space. Yeah, Microsoft is really a pioneer in this tele-immersion scene. So I guess most of you have heard about the Holoportation. They build a system that reconstructs in really high quality persons from capture rooms, within capture rooms, as 3D mesh. And actually what it can do, it compresses that and renders it in the HoloLens. Microsoft uses, especially for this use case, uses a capture room that consists of 8 camera pods. Each camera pod is customized, so you have 2 infrared cameras, 1 RGB camera. And what they do, they build a temporarily consistent mesh of the person and the objects within this capture room. And then they try to also estimate the deformation of this mesh. One of the drawbacks, of course, is you have a costly and really large setup, and you need really high-end computational power, because the focus of Microsoft is really like having a high-quality reconstruction that's really near to the real-world objects. They also try to build a mobile solution, so they crunched all this system down to size that it fits into a car. And there's one guy in the back, sitting on the back seat. Actually, it's captured on the back seat and then transferred to a person outside of the car. They got it down to 30 to 50 megabit per second, basically. But still, you have a really customized system. And at Viscopic, we just thought about, is it possible at the moment to build a prototype with technology that is off the shelf, that is usable at the moment, and with using the infrastructure requirements that are usually there or achievable. So we want to have an affordable solution. So a feasibility test for an affordable solution should be available, so off-the-shelf components, and usable means like using current network infrastructure. So we came up with a really rough prototype, how this can look like. So on the right, you see what we came up with. Left, you see like the Microsoft Holoportation thing. What we did is actually we built a Kinect capturing system that captured the person in 3D. And we render that for the HoloLens, inside the HoloLens. We also don't use holographic remoting yet, but this could be an improvement. You see the quality can definitely be improved, and this was just a vertical prototype to get an experience if this is technically feasible. So what we achieved is that this experience, of course, is not full body reconstruction, but we got down to less than 15 megabit per second, what it definitely can transfer via the internet, also globally. And on 30 frames per second, we use Kinect version 2, so like off-the-shelf hardware and really affordable computational hardware to bring that experience to life. How did we do it? Actually, we have one client for each Kinect that actually gathers and acquires all the dev data. And we have one server that does the mesh alignment, the predictive edge breaker compression that we use, and we transfer that to a HoloLens to render. The main limitations currently still are, of course, bandwidth. This is the main limitational factor here. We see there's a lot going on like in the compression side, but also like 5G technology can improve that, especially in the capture room. Field of view, definitely a problem, especially with HoloLens. So this can definitely break the illusion of teleporting persons. But I think HoloLens headset field of views get larger. And eye contact. So current devices definitely lack on the possibility to see the eyes completely clear and the faces, which is important for social interaction. So Google, for example, did this facial overlay using eye tracking with HTC Vive. Microsoft also piloted this or did this in the Microsoft Research, where they used like the HoloLens without covers to make like the overlay of the facial reconstruction. The last 3 slides, I want to talk about applications. There's obviously one application I really like. In the future, I think there will be definitely a reduce of travel costs, especially in the consultancy industry, when you have the ability to really work together on flip chart and whiteboards in the same room in a 3D space. Broadcasting events, like not just the concert events that we saw, but sitting on the couch at home and like feel like you are immersed into a sports game and seeing the players in 3D walking around you. I think this is really a powerful and really nice experience. And another use case may be in surgery, means like a surgery room is definitely a highly critical area, so there shouldn't be any spectators like blocking the people working there. But to educate the medicine students, it's really necessary that they get the experience and also the on-site experience, so to say, in the surgery rooms. So ideas to capture in 3D these rooms and to give the medicine student the ability to experience that surgery in like in 3D and from the perspective of the doctor. So that actually was my presentation about that. Thank you very much. I'm really inviting you to reach me out on any channel, like on my Slack, email, also via the event app. I'm here until tomorrow. Also, if you want to collaborate with us on this, definitely interesting as a research for us. And thank you very much. Have a nice day.
Awesome. Thank you very much.